Well, good morning, good afternoon, good evening to everyone, wherever you may be across the wonderful planet. Thanks so much for joining us here live today for Serverless Office Hours. And we're streaming on the AWS Twitch channel and on the Serverless Land YouTube channel and also LinkedIn Live. My name is Julian Wood. I'm a developer advocate for Serverless at AWS. And today I'm super duper happy to be joined by the one and only Ran Isenberg. Ran, how are you today?
I'm fine, thanks. How are you?
Excellent. I'm good, thank you. It's slightly late in the day, so Ran is doing an extra long hours. He's based in Israel. He's not just a software architect; he's a principal software architect. So that's pretty high up at CyberArk. And I know CyberArk well. Actually, the last company I worked for was a decent customer of CyberArk. So I probably use CyberArk tools on a day-to-day basis, and they were pretty cool. So yeah, that's the day job. But then I suppose on the side. Ran's an AWS community builder. So that's one of the cool things, that you get to build stuff for the community. So yeah, Ran, tell us how you sort of got into AWS and how you landed up doing all the cool things you do.
So I'm a software architect, principal software architect at the platform engineering group at CyberArk. And part of my job is to help teams to move from on-premise solutions and products to more serverless, SaaS-oriented on AWS services. And we build SDKs, we design services, we build training, we help them move to the cloud and practice best practices for serverless, Lambda functions, all this whole amazing world. So that's how I got into AWS. I basically knew nothing about AWS when I first started. I came from the more Kubernetes background. And it was, I think, over 3 years ago. And we started to learn about serverless and work with serverless and ask questions. How should we do that? How should we do input validation? How do we handle observability, deployment, all sorts of things that you need to do in the serverless domain? And I stumbled across the AWS Lambda Python repository, and I did some code contributions. Then I learned of the AWS Community Builders program, and I applied, got accepted, started writing blogs, making more talks, more developer advocates, projects, so to speak, speaking conferences about the work I've been doing, about solutions, designs, best practices. So it just keeps rolling and rolling, and I'm doing more and loving it, basically.
Excellent. Well, we're super happy that you're creating all this good content that we can use and consume. So that's super great. I think it's fascinating. I also come from a sort of enterprise, maybe sort of on the infrastructure background, and so the idea and concept of sort of you being in a platform team as well and being able to enable other people to be able to consume the cloud and do better things and have best practices spread across an organization is something near and dear to my heart. So yeah, excellent. So we are going to be getting onto a lot of stuff that Ran's talking about, but yeah, just quickly looking about what's happened in the past week of serverless. Last week, Eric Johnson and Dave Boyne were talking about EDA visually explained. This is event-driven architectures. Dave is putting together all his awesome wisdom about events and putting them into little bite-sized nuggets of awesomeness that are little visual things on serverlessland.com. And yeah, really they had a great chat about that and some of the real cool patterns that you can also build on based on event-driven architectures and sort of bringing them to life with some visual things. I'm a visual person, so it certainly helped me to understand how that all sort of works. In terms of what's new with AWS, well, some kind of things we're going to be talking a lot about Lambda Power Tools later for Python, but actually the Power Tools for .NET is now generally available. So that came out last week, a whole bunch of tools initially on the observability space for making Lambda and .NET really work much better together. Reduce your own code, pull in the libraries for .NET, and you're going to be off to the races doing much better stuff. Also, if you're wanting to integrate Lambda with even more kind of things, well, DocumentDB chain streams can now become an event source. Works pretty much the same way as DynamoDB, and so any changes to your DocumentDB can just flow through to your Lambda functions, and off you can go and process them. And talking about processing things at speed, well, Kinesis is often the good tool for that job, and the on-demand write capacity throughput limit has now been raised to 1 gig a second. So if that's something that's of interest to you, well, hopefully that will help. In terms of some serverless blogs, just looking at the top two, multi-part upload and transfer acceleration. So a really good blog post about this. Just some cool ways that you can use S3, which is I don't know, probably arguably one of the world's largest object data stores, and now you can use it even faster using a serverless approach. And then also interesting from Yuri, and Yuri is also a specialist serverless architect from AWS within Israel. So obviously lots of super duper brains in Israel. And Yuri's done a really good post on developing portable Lambda functions. So this is all about something. Lambda functions don't have to be written specifically for Lambda. Yes, they do in some ways, but what you can do is you can write your Lambda functions and separate some of the procedures and functions out into various kind of things, makes for the testing simpler, and also makes for the portability. So that little Lambda handler that you've got can be specific for Lambda, but the rest of your code can be very generic and could be run even on-prem or in a container system or even on EC2. So that's super helpful. That means if you're not quite sure whether Lambda is the right thing for you, this may give you a little bit of oomph to at least try Lambda, knowing that if you do need to move it off it at some stage, it's not going to be that much work. So that's looking over the past week, but this week we're talking about the Lambda Cookbook with Python. I do enjoy my food, so anything to do with cooking is going to be super useful. Ran, over to you. I know this is an open source project that's near and dear to your heart that you've been working on. Tell us about the Lambda Cookbook with Python.
Yeah, okay. So let me explain the incentive, right? The use case. So like I said, we started to work with serverless technology and really dive deep into the word to understand what it means to create a serverless application. And usually when you start to create a serverless application, it might be a bit of an overwhelming experience because you need to solve many, many issues that have nothing to do with your business domain. You need to figure out how to do CI/CD, how to deploy to the cloud, what framework to use, how to write Lambda functions, what are the best practices, how to handle observability, logging, metrics, all these things that are not really related to your business domain, but you kind of have to do them, right? How do you do testing in serverless? That's a big issue. So once we figured it out at CyberArk, well, at least we're still trying to figure out many of the issues, but we have a template in a template at CyberArk that teams can take, and with several clicks just start their serverless service, right? They undergo training to understand about AWS and how to work with our internal SDKs, and then they can just start their template to create their own new service, and they can just add more tests, they can add more Lambda functions, and we teach them how to do that. We teach them how to write tests, how to do the CDK code, how to debug the code, and they have something that just works. All the things that they are around serverless, right? The CI/CD, the testing, the CDK code, everything is it's there, it just works. So they can take the code and they have a make file, they can write make deploy, and it's going to deploy the service, and then they can just add breakpoints in the code and debug the code. So it makes the development, it really accelerates. It makes them the onboarding experience is much easier and much simpler. And in one case, we had a team that came from C++ on-premise products, and they started to create their serverless Python-based service. And they went through this training and the template, and they did everything. They created their new service, and it took them 4 months to start from that training with the template and all the knowledge and all the best practices, 4 months to get into actual customers. So wow, that's pretty fast, to be honest. So I decided at one point, well, if it works for us internally, why not make an open source version of it and share the knowledge? I mean, I was already writing blog posts about the best practices and things that we've developed and things that I've learned and things that we've understood. So I said, hey, why not create an open source that everybody can start their serverless service, and basically just 3 clicks in GitHub, and you can have your own deployable serverless project with all the best practices, with CDK, testing, and a pipeline that works, a make file for fast developer experience, and just start writing code. So no, that's basically
I think that's fantastic, because I mean, we all say quite. I mean, it is correct that the on-ramp to serverless can be simple if you look at it at just the aspect of take your code, zip it up or a container image, send it to the cloud for Lambda, for example, and it's going to run at pretty ridiculous scale. Oh, and that's it. Pretty simple. But we know also around the scenes there's a lot of stuff that needs to go on to make that a well-architected service. We want to have our metrics, and we want to have our logging, and we want to have our input validation, and all these sort of well-architected goodness that we want to have as a part of a production application. And yes, some of that is code, and some of that is in config. And developers just want to get there and they do their code and do their testing and do all that kind of stuff. And I really love this idea of building a sort of whole scaffolding on-ramp. Maybe that's a bad metaphor, but the scaffolding that people can get going quickly, and then this on-ramp that people can just deploy something with a few clicks and they can get going. And I love also the experience of somebody can do that when they're brand new, and that means then that they can then look back at the repo and they can sort of understand where all the little bits and pieces have been added. So yes, I think it's fantastic.
Yeah, well, thank you.
So also just before, I forgot to say in the beginning, because I'm obviously must be half asleep today, but we are live, obviously, so please send us your questions and comments. We've got some coming in already. TS joining us via YouTube. Serverless is awesome, good stuff, guys. Thank you very much. True. Serverless is awesome. Good old AJ Isenberg. Always love having you and talking about you. Yeah, when I mentioned that Ran is a member of the Community Builder program, of course, that is super good. And also to Itai for via Twitch as well, also talking about the YouTube thing. And then Daniel Abib, who is joining us from Brazil, and he said hello from Abib as well. Amazing, this type of knowledge sharing. Exactly. This is why we have the experts on to talk about all the cool things that we're going to be talking about. So yeah, Daniel, hello from Brazil, and hello from everybody else where you may be coming from. So yeah, questions and comments, please send them on, and myself and Ran will try our best to answer them. If we don't know, well, we don't know, but we'll give it a go.
Okay, so do you want me to show the
Do
project?
you want to show your screen? One thing, because we have covered Lambda Power Tools, which you were talking about. So Lambda Power Tools, which I spoke about just being for .NET, but also it is for TypeScript and Java and Python. And have I missed someone? 1, 2, 3. I think they're 4. Anyway, hopefully the internal people are going to get me wrong. Tell me if I'm wrong, if I missed a language. I think I've got all of them. Yes, so tell us about Power Tools. And I know you've also been. It is open source, and you've been a contributor to Power Tools. So if you can just give us a brief overview of Power Tools, and then what you've added to make it even better.
Okay, so it's an AWS managed open source repository on GitHub. So I'm using the Python, obviously, because I'm a Python developer. And basically, it's an amazing repository because it's a collection of many best practices, proven best practices and utilities that you should use basically in your serverless service, and they save you tons of time. It's really simple to use, and it doesn't make any sense not to use it, to be honest. So it covers logging, metrics, observability, batch work, input validation, feature flags, and lots of other utilities that I forget at the moment. But it's basically just quick start to serverless best practices, to be honest. So in my repository, I'm showing how to use the utilities, how it all fits up in a real serverless application, not just in the documentation. When you look at the snippets, it's a real product that you can see how you should use it. That's in a nutshell.
Excellent, Paul. Thank you very much. And what I know you've contributed to part of it, and I think one of them has been some of the input validation.
Yeah, the parser. That was the first code contribution that I've actually ever done, and I've learned so much about it. And for me, it made a huge difference. Just started like a roller coaster of doing new things and speaking about it on Twitch, and then going to conferences and writing blogs. So it was like it was a big deal for me. I mean, that specific code contribution and the AWS Lambda Power Tools team was amazing. It really helped me to contribute the code, and they listen to feedback. And I've learned a lot from the tools that they use and the methods that they implement. So it's a really great team. And once I did that, I added more services to the parser, to the input validation. I think there's over 10 AWS integration services that integrate with Lambda that we now support. And also contributed the feature flags. But both the parser and the feature flags started as a side project that I did at CyberArk, and at some point said, let's contribute them and help everybody. I'll help the community.
Perfect. Well, thank you. And even personally, internally, some of many of the people who work on the Power Tools for the various different languages are literally some of my favorite people inside of AWS. They seem to go above and beyond in sort of being helpful and doing as much as they can as quick as possible. Even an example last week when .NET was coming out, they realized that there were some things that maybe weren't the same in all the documentation across all the different languages. And so there was a huge push to get that sorted out and done. So, a lot of work going on to try and do the best things they can. So yeah, that is the link for Power Tools for Python. And I will shortly put the link to Rand's blog and also the Lambda Handler Cookbook as well. Brent, do you want to share your screen and then we can have a look at some of the cool stuff?
Mm-hmm. All right. So let me know when you can see the screen.
There we go. Yep, screen is on.
Okay, so that's the repository, the AWS Lambda Handler Cookbook. And like I said, it takes 3 clicks. 1, 2, and then you choose the repository name, and then you create the repository from template, and that's it. Congratulations, you've got a serverless service that you can start to use. And if we go, I think that documentation is a big part of any developer experience and any open source. So there's a link here to the official documentation that I wrote. So this is the homepage. I have a website, it's called Around the Builder. And I started it as the Lambda Handler Cookbook was the GitHub example for the first blog series that I did about best practices for Lambda, the AWS Lambda Handler Cookbook. But eventually, I became more consistent and started writing more about serverless best practices and things that designs and features and cool tricks and tips and stuff like that. And this project also evolved over time. I added more content about how I think you should do things. And the project itself got bigger and bigger. So as you can see, I stated the problem here. I want to help you. I want to help newcomers to serverless, maybe also veterans to just, check themselves that they're doing good things. And again, and by the way, I'm looking for input. Maybe I'm doing something wrong. Maybe you have a better way. Maybe you like it. Maybe you don't. Please open issues and contact me about feedback. I'd really appreciate it. So like I said, again, we're going to solve several issues. I'm going to present you with how you can do deployment to the cloud. I chose CDK, which I'm a big fan of CDK. There's a GitHub. There's a CI/CD pipeline that really works, and it deploys to AWS account, and it uses GitHub Actions. And there's all the Lambda handler has the observability and login tracing, metrics, input validation. The project structure is the recommended one, also according to the AWS well-architected framework. The handler segregation between the logic layer and the handler itself. There's also my best practices for testing, which I wrote a blog piece about a week ago. And next Monday, I'm going to publish the other part where I actually go about tests from this project and explain why I wrote them the way I did. So that's on Monday. So what are you getting in the end in this service? You're getting an order service, right, where people can purchase a product. There's an API gateway that triggers a Lambda function that saves the request data to DynamoDB, and it also uses app-config for configuration and feature flags and dynamic configuration. That's the basic template service. I didn't want to make it too complicated because you're going to take it and you're going to make it your own. You're going to change it. So it should be simple enough with concrete examples that you can follow. So I think maybe we should jump to the code if there are no questions. And I'll show what you're getting.
Yeah,
really.
while you jump to the code, there was a comment earlier about testing, so I know we're going to cover that. So yeah, TS, again, thanks for joining us via YouTube. What's the best practices for testing Lambda functions? Well, we can start with this repo to load, and there's going to be plenty more info as well.
So if you don't want to wait until I speak a bit about it, there's the link here to my first post about it. Like I said, on Monday, I'm going to release the second post. Let's go to the project itself. So,
and then Alpa codes, yeah, quickly just to jump in with your question. Can we use TypeScript power tools with JavaScript? Quick answer, yes, you can.
Yeah. Like I said, this is a more Python-oriented project, but the best practices and approaches are still irrelevant to other programming languages. Just the tools of the trade, I guess, but the same principles apply to different languages.
Yeah, and you can use the TypeScript power tools with JavaScript. All the transpilation, everything happens seamlessly.
Okay. Okay, so what you're getting, okay, let's take a look at the project structure. So I have the CDK folder. That's where the CDK stack resides with all the constructs. I have one construct here with the, I did a segregation between the, you have the database construct, because maybe today you have DynamoDB, but maybe tomorrow you're going to have an Aurora cluster. So I think it's best practice to have it in a different construct of its own. It's also reusable that way. I can share it between teams. And then on the API, I have the API gateway and all the Lambda function, the one Lambda function and its role. And I also use Lambda layer. I'm a big fan of Lambda layers. I think it's a great deployment optimization. And if you're interested, you can read it in my website. So that's part one of what the CDK folder is. There's also the service. The service folder is basically the business domain where you add your own code. And again, you have the handler folders, and you have the create order handler, and it has its own schemas for input and both output. There's the logic layer and the database layer. And there are also general schemas like exceptions that are global around the handler and all the layers. And before we dive into the handler, there's also the tests. And the tests, I think that's an interesting approach. I have unit tests, integration tests, infrastructure tests, and end-to-end tests. And other than that, there's also under GitHub, there's the workflows, there's the serverless service. That's the GitHub Actions CI/CD pipeline. That is defined here. And the one important thing that I wanted to really preserve is developer experience with the CI/CD pipeline. So usually developers, they will push the code and it will fail on the pipeline. They will not always understand why, and they will try to fix it and push again, and then it fails again, and they start to kind of debug on the pipeline itself. I think that's a horrible experience. So I really aimed to have the same commands, the same commands that you run here, you can run them locally. So if it fails locally, it's going to fail on the pipeline and vice versa. So you don't have to waste your time. You're going to use a makefile that has all the commands that you need, basically, and you can emulate whatever you need to run on the pipeline. You can emulate it locally. There's also a pre-commit hook, and I also added a command called make_pr, which basically sets up your code for the pipeline. It fixes automatic linters and file formattings and stuff like that automatically, and then you can just push it. And if the make_pr command passes, you know for sure that your pipeline is going to pass, okay? Because it's going to run all the linters and all the things that you need and make it right. And I did forget to mention about the CI/CD pipeline. It's specifically made for Python. I think the concepts are also relevant for other languages. So you have the pre-commit where you fix all sorts of string stylings for Python. Then I have Flake 8 for study code analysis and MyPy for more type-oriented study code analysis. I have file formats with YAPF, which I really like from work. It's very fast. I have complexity scan, which if you're not familiar with complexity scan, it basically tests how complicated your code is. If you have lots of for functions and then switches and ifs, you're gonna get a bad grade, like A, B, C, D, and if the code is too complicated, it has too many nested conditions and flows, it's gonna fail your code, and you're gonna have to refactor it. And the idea here is that if your code is too complicated, it's gonna be more costly and more hard. It's gonna be more costly to maintain it, and it's gonna be more complicated to understand it. So I think that's a nice gatekeeper for when you should refactor a function into a helper function, or maybe refactor an entire piece of code. So that's a big deal. By the way, I learned that from Power Tools. I wasn't a Python expert, right? So I learned about it runs basically Raudon and Xenon for Python, and I've learned that from Power Tools. So that's another cool side effects from open source.
Yeah, I didn't realize that as well. I'm learning new things every day. Cool.
Yeah, so that's really nice side effects for doing open source contributions. You learn from other people, and then you can bring these best practices into your own organization. So we're using these tools also at CyberArk. So thank you, Power Tools. And then you have unit tests, and then the infrastructure test. Then we deploy to the cloud, and we run the integration tests and the end-to-end tests, and that's it pretty much.
So what would the infrastructure tests test?
Okay, so unit tests, I think they're I think we understand what unit tests are, right? They're isolated parts of code. You have specific input and output that you want to test. You don't require deployment to the cloud. And I usually use them for also input validation for schemas that I use with Pydantic. And infrastructure tests are also run before deployments to the cloud. And you can test two kind of tests there. You can test, I'm using, if you're familiar with CFN NAG, Cloud Formation NAG, there's the CDK version. CDK version, CDK NAG. So basically, it takes your stack, it synthesizes it into CloudFormation template, and then you can run checks. So this check is the AWS Solutions Architect security checks, all the best practices that they defined. Here, there's another standard, the HIPAA standard security checks. So it checks perhaps if you have an S3 bucket that has a public open to the public. Maybe you have an overly privileged role. Maybe it has a resource of asterisks. So things like that, things that you don't want to find out after you deploy. You want to catch them before you deploy to the cloud, so you don't expose yourself to any security risks. So this is a nice way to really do that. And you can add, I think, your own checks and your custom checks. I'm not an expert of this utility, but I think it's really important to at least use these, well-defined standards that very smart people define. So,
and I like this. I like this approach that, in a way, developers are very used to developing locally on their machine, and we do ultimately want to test a whole bunch of stuff in the cloud. But there is can be a little bit of a time lag with that. Things like SAM Accelerate and some of the CDK sync can improve that. But if you can give power to your developers to really quickly be able to, run your infrastructure tests just locally, and you're going to, catch that incorrect permission or check something like that really early on before you even got to the cloud, and it's going to be super quick. I think that is super important. And I also think this is the cool kind of things you can do in a bigger organization, in your kind of team when you're a platform enablement team, where they can be involved in creating these hypertexts and all the different nags and serverless rules is another one. And you can, centrally manage them, centrally control those, and they can just flow down into your repos. So as your developers are coding things, they get that feedback immediately. It's not, 15 minutes after a long CI/CD pipeline that's like, oh, here we go.
Yeah, that's true. That's really true. By the way, I didn't mention it, but I just said it casually. But as you can see, the infrastructure code, the CDK code, and the service code, they're both together in the same project, and they're both deployed and also tested together. So that's like a big part of the equation here. Developers write infrastructure, we do DevOps, the DevOps mentality, we own it, we deploy it, we maintain it, and we also monitor it. So that's a big thing, that the mentality that you don't have like this DevOps engineer personality who's going to do that. All the developers do that, right? We are all DevOps. That's I think a very important aspect of this underlying folder structure.
Yeah, and I love this folder structure because it shows some of the sort of big organizational learnings. Got my wrong word. And actually, I did a Serverless Days Belfast was last week, and I did a whole talk on literally how you can what serverless means, or half the talk was what serverless means from an operational point of view, with a bigger picture thing of serverless makes your operations a lot easier because there's less you have to do. But then conversely, it allows you to spend more time on this kind of thing where you can really get good at these kind of tests, and you can, spread it all over your organization that you can do this really well. So yeah, I think this is super huge and important.
Yeah.
And just to come in, Alpa Codes, thanks for the question from Twitch. Is there SAM nag? So the question is, there isn't actually a SAM nag, but because SAM generates CloudFormation under the hood, CFN nag is going to work literally in the same way. So, that's going to be that's going to work close enough. And then, I suppose the question is, how long do the infra tests actually take?
Less than a minute. I think 30 seconds or so. It really depends. But I mean, it depends on the size of your stack, to be honest.
Yeah.
But yeah, it's quick. Should be quick, and you can run it. You can run them in parallel to the unit test. So.
Yeah, and obviously you're not going to be running unit infrastructure end-to-end and integration tests as you're doing everything testing. You're going to be testing your business logic, doing your unit testing. As soon as you're then thinking, okay, I now need to move it to the cloud, and then the remit of your test is going to get bigger and bigger. So you're not running a minute test all the time. This is hopefully a one-off, fix something, and then you're done.
Mm-hmm. There's also another aspect of the infrastructure tests where you want to make sure that you're not making any mistakes, so to speak. So we're deploying to the cloud, and we're writing code, and the CDK code gets translated into CloudFormation, and then you deploy it. So one common mistake that I saw is that people want to refactor the code and they move objects from one construct to another without realizing that by doing that, they essentially changing the logical ID of the resource.
Oh, yeah.
Now, it shouldn't be that much of a problem unless it's a stateful resource, like a database, or maybe it's a role that you use it to have like a cross-account access trust mechanism. And when you change the logical ID, you basically destroy it, and then you recreate it. And if it's a database, oops, I deleted all my data. So not a great experience. There's also another issue where you might have exceptions in CDK. This is very rare, okay? But it happened once, I think, in 3 years. So I still remember it. You can have exceptions that somehow don't crash the deployment and don't cause a revert. And then you can end up having your stack without, in the synthesized process, I mean, you can have your stack without one or more resources that are really essential, right? Maybe an API gateway might be missing. Maybe your DynamoDB table might be missing. So you want to make sure that the CloudFormation template that you're going to deploy has all the resources, all the critical resources that you want to check. And also you can add here to check, you can add the check for the logical ID. You can make sure that it does not change even by mistake. So if a developer changes it, this test is gonna assert that, hey, the logical ID is not what I'm expecting. I'm gonna stop you, and you're not gonna deploy the code and recreate the stateful resource again. So that's more like catching the edge cases, so to speak. Yeah. But it does happen. So I think it's important to have at least some of those resources.
Okay, and Alpa Codes has just come back with, so the infrastructure tests are not deploying any resources, they're just generating CloudFormation, then statically analyzing that CloudFormation.
That's true.
Cool, thank you.
Okay, so that's about infrastructure. So if we're in the tests domain already, I can talk about integration tests. So before you go to the integration tests, you need to deploy your code. So you write make deploy, press enter, and it's gonna deploy your stack. I already did that, but it works. It deploys your code, and then you can just run the integration test. So what I did there in the integration test, I basically, let's take a look at one of the tests. I'm gonna test that my Lambda function, my handler, returns back HTTP 200 OK, and I'm gonna create its input, and I'm gonna build the input that it expects. It expects an API gateway event. I'm going to generate a demi event like a customer name. My name is Ron the Builder. I want to purchase 5 items, and I have a tier, a premium tier, and that's the input that I want to send. And I trigger the Lambda Handler function with the event, and I assert the response that everything is okay. And I also assert here the side effects of the function. I assert, and here I work against real AWS resources. And the function also, if I go into the function, it's gonna do the input validation. I'm gonna show that in a second, but it's gonna work with AWS real resources because that's what I want to experience. I want to test that my code really works locally with all the configuration here and all the presented input. And I want to check that the side effect, that the table I really added the item into the table. And not only that, the item was correctly added with the customer name and the correct order item count. Okay, and then I can check more, edge cases. I can mock exceptions. Maybe the DynamoDB save put item function that I'm using to save the item, maybe it raised an exception. So I want to catch the exception in the Lambda function, and I want to assert that I'm getting back an HTTP status internal server error. Now, this is the only way I can do that because DynamoDB is not gonna, it's like 99, I think like 99s, right? Yeah. It's not gonna fail just because I want to simulate it in the test. So this is a great way to simulate failures and edge cases in your code. And I can do it only with this kind of tests. When I run it locally, I run the code locally, and it's super simple. I just run a regular PyTest with breakpoints, and I mock whatever I want to mock, and and I don't mock what I don't want to mock. If I want to use a real AWS resources, I'm going to use them. If I want to simulate an error, I'm going to simulate an error. So I added all sorts of failures and things that I want to check and see that everything is working properly, and I have no crashes, so to speak, in my code. So that's how I handle integration. Just create an input, call the Lambda handler, do the happy path, check side effects, and then test edge cases and make sure it works as you expect. That's the integration tests.
Yeah, I'm just thinking it would be so nice to have a sort of library of the kind of unhappy path tests. I'm just thinking of the top of my head, something I need to chat to our testing people in the Lambda team as well. Or, something SDK generated or something, because obviously this is a lot of testing code you generating, and you're having to think of all the failure modes for DynamoDB. That's made me think about how possibly we can make that better. So if yourself or anybody watching has any bright ideas that we can improve the Lambda service by having a better way to write these tests, that would be great.
I think it's even more. I think there's an easier solution. I mean, at least in this category, I have this function, generate API gateway event. So one of the issues with Lambda's it's one of our its characteristic.
I think we get what you're talking about.
Okay. You do. Yeah. Sorry.
Not at all.
It's late here. So it has numerous integrations with many services. So in this case, this is the envelope, right? The metadata that API Gateway sends to the Lambda. And all the way here at the bottom, I think you can see where's the body parameter. Yeah, here. So all this is added by AWS API Gateway, and then you have the body, which is a string. As if you recall, I sent a dictionary, but it reaches the Lambda function as a string, which is different. And every service, Event Bridge, SQS, SNS, they all have their own envelopes and schemas, and the payload in one service is body, but it's string. In other, it can be a dictionary or a list of dictionaries, or inside a list. It's a completely different. And sometimes the documentation is good, sometimes it's not so good. So that's why we use the parser at AWS Lambda Parcels, because it knows the schema. But we still need to generate the event itself when you do this kind of test, like I did, because my Lambda function expects a real event. So it would be great if we could have these helper functions readily available, so I could just generate and inject my body, my specific body that I want to add. Because what we did something like this internally, where we have some factory generators, and everybody use them, but it's basically everybody has this code. Every organization has the same code and needs to maintain it, and it's super annoying.
Because you want a custom body, otherwise, you can use a number of tools to generate the full events, but then you want to customize the body for various tests.
Yeah, not only the body, maybe the path, the headers. All sorts of things that you need to mimic authorization, authentication, and query params, whatever. But the structure is still the same, and everybody has this same function, and they're doing the same thing.
Yeah, good idea. Yeah, Alpa Codes, thanks for all the cool feedback. Is there a way to actually test exceeding concurrency limits? It's an interesting one.
Yeah, but not on an integration test. That's why you have the end-to-end tests, which bring me to the end-to-end tests. So the end-to-end tests are basically, we're creating the same input, but instead of calling the Lambda function itself, the code itself locally, I actually mimic the customer flow, and I call the API gateway with the same way that any customer would, and it runs entirely on AWS. It does its own thing, and the Lambda function runs with its environment variables and the zip file that you load, the Lambda layers that you have, and the role and the permission. Everything is real, right? Because when we ran it and the integration, I use my own role and the environment variables that I defined locally, and the CPU that I have on my machine, and everything is local. But here you're running the real thing from start to end, and as you can see, I'm just asserting the response. I'm not going to check the side effects because I already checked them in the integration level. And here my guideline is to use strictly official API flows, and just if there's a create order, then call the get order and make sure that you're getting the order that you just created. I don't have a get order API here. It's just one Lambda, but you get the point.
Yeah.
But here I can also test bad use cases where I present an invalid input, or maybe invalid authorization header, and I expect it to fail with a certain HTTP code. So that's a very important security test, end-to-end test that you need to do. Because if you have a cognito authorization and you want to make sure that if you send a request without the authorization header, it's going to fail. Because if you misconfigured something, you're going to have a security breach. So that's a very important end-to-end test. And if you want to test your concurrency level, you're going to have to generate some sort of a performance test. And I am just generate multiple requests and just test your machine. We actually did that several times. I think that every service, before they go to production, do that, and for some time test that also. So the performance test I also categorize under end-to-end flow, to answer the previous question. Can I show the handler itself?
With pleasure, yeah.
Awesome. Okay, so this is the create order handler. So lots of power tools here. Okay, really lots of power tools. So we have we're using the logger. Okay, the logger is a JSON structure logging, outputs to CloudWatch logging. Awesome utility, very simple to use. We're using a correlation ID that allows us to search in CloudWatch a specific ID and see all the logs of the same invocation. Otherwise, we would have to. Usually, when you look for logs, before I used correlation IDs and things like that, I used to write in the code reviews, please add this field and this field to the log, and people would forget. And then when you look for this field, you would see just parts of the logs of the Lambda function and not all the logs. You wouldn't have the full flow of the function, right? So with this one simple line, you're basically saying, okay, this is the correlation ID, and I want all the logs to have this ID printed as part of their logs. And then when you search for this, when a customer says, hey, this is we got this error, and this is the correlation ID, you can search for the correlation ID, and hey, this is the entire flow of the request, and I can see what happened and how we got to the error. So it's very powerful, the correlation ID. And also you can pass this correlation ID between services, and then you can see like a whole observability flow between services. I can talk about these things forever, but let's continue. We have the tracing. The tracer is part of the AWS X-Ray integration built in. I've used it, I think for about 2 weeks. I used it to chase down bottlenecks and performance in one of our login services to our platform at CyberArk, and it helped me to reduce, I think, to improve it by 70%.
Wow.
To reduce the time of the login. A great utility, really, really great when you're looking for performance bottlenecks and really understand how your service operates and how it connects to other services. Every API request that you're doing to DynamoDB or another external service or internal service that you have, you're going to see the maps. And if everybody's using X-Ray, then you can have in one single page, you can see, I have this service it runs, it sends a synchronous request to another service, and then I can see how the request went in that other service and what's the bottleneck was there, because it affects my service, right? It's a synchronic request. So it's a great utility to really understand why things take time and where's the bottleneck. And you can even add it at the function level, right? This is at the handler level, and there's a decorator to really catch specific functions to really understand how much this function takes. So that's a great utility. There's the metrics. The metrics, I use them for writing custom metrics, custom CloudWatch metrics, for basically to understand how your service operates. You can specify custom metrics to really understand what features people are using, how often, just to make a better understanding of usability behind the scenes, to maybe spend more time on specific parts of the service, or just have a dashboard for today. This API was called 80 times by this tenant and 20 times by this tenant, to really understand who's using the system and how. So it's a great utility. Very simple to use, to be honest. Metrics, you can see, you just call it metrics, add metric, name, unit, an integer, and the value. It's super simple.
And this is also using the embedded metrics format, which is asynchronous.
Yeah.
So it's not going to hold up your Lambda function at all. And it's literally just dumping that info into CloudWatch logs, and then CloudWatch metrics actually pulls it directly from logs. So you don't need some sort of crazy process to go and generate that yourself.
That's magic, actually. It writes the logs into EMF format, and then it disappears from the log magically and appears as a custom CloudWatch metrics. which is great if you also want to integrate your metrics with Datadog or other services. So it can just be done like that. Instead of writing code, you send this metric to Datadog with this specific SDK. It's super simple and very performance oriented. This is another utility that I wrote. It's not part of PowerTools, but it should be. I think everybody should do that. It's basically testing, loading up your environment variables according to a schema. I'm using Pydantic, and I want to make sure that all my environment variables are valid. They're there, and if there's a value constraint, I want to make sure that the value constraint is okay, because people use environment variables all over the code, and they don't always check that the value is okay, that it's not empty, and then you're gonna get crashes because maybe you don't have 100% code coverage. I don't want to be surprised. I want my configuration to be perfect, and I want to catch it as soon as possible if there's an error. So I have lots of environment variables for PowerTools, for the PowerTools logger and the log level, and for app config I have. And then I have my own custom, my business domain environment variables. I have a REST API that I might be needing, and the table name that I use to write to DynamoDB. So I want to make sure that it exists in this case, and it's not empty, right? The minimum length is 1, and it's a string. So it's super important. And here, the REST API, I want to make sure that it's an HTTP URL. So it's not just a string. I really make sure that it's a valid HTTP URL. So it's a value constraint check. So it's super critical, super powerful check. So I know that if I'm going to use that in my code, once the decorator, the init environment variables passes, I know that I have perfect configuration. And here we have the parser, which, sorry, that's the, this is the feature flags configuration. It fetches configuration as a dictionary from AWS App Config, where we store dynamic configuration, and I can use it wherever I want in my service. I just want to make sure that I can fetch it. And dynamic configuration, just in a nutshell, as you can see, environment variables are static configuration. I deploy the Lambda, it's there, it's not going to change. I can do, if environment variable is like that, do thing A, otherwise do thing B. That's okay, that can work. But if I want to change the behavior of my Lambda function without redeploying my code, because if I want to change the environment variable, I need to redeploy my code, then environment variables are not going to cut, right? I always have to deploy it. So when I say dynamic configurations, I mean that they're changed elsewhere. They're not part of the Lambda itself. They're stored as app config configuration. They have their own pipeline where we change the values, and every invocation where the Lambda starts, it fetches the configuration, and if the configuration has changed, it's going to do something else. If it's the same, it's going to act the same. So it's this is the dynamic nature of the configuration that app config provides us. So PowerTools also has this kind of utility. It also has more capabilities, such as A/B testing, where you can enable features from some customers but disable them for others. So it's a very, very powerful utility. But usually you use it down the road when you're more production ready, when you have more understanding of a business, and you're usually doing it later on. So this is the input validation part, and it's obviously very important to check your input. You don't want to have all sorts of security hacks, attacks, injections, and things like that. So we're using the parser. I'm telling it, hey, please check my event. The model that you're expecting, I call it input. It's the customer name and the order item account. And again, I'm using both value constraints and type constraints. So order item account is a positive integer, non-zero integer. And the customer name needs to be a string. I decided that it should be 1 to 20 bytes of length. And I need to tell the parser, hey, you're going to expect an API gateway type of event. So it knows how to parse and find the body string, if you recall, because like I said, every Lambda integration has its own envelope type, so the event looks completely different. And then once we get here, we actually can start working. So we call the logic domain, because the handler, all it does is load configuration, check the input, call the logic with the input, and get returned back the output. As you can see, it's very clear here. You're calling the logic. This function is in the logic module of the handler. It sends the input, also the table name that it requires, and gets back an output that you return back to the caller. And you catch any internal server exceptions, and then you know how to handle them and how to return the response back. That's in a nutshell, the template. Or this is like a template of how to write handlers. So whenever you have, and it doesn't have to be an API gateway, by the way, because if you want to have a handler that gets another event, just change the envelope here to SQS. Now you have an SQS handler. So this is just a very template way of writing a handler. And all you need to change is just the logic domain and do whatever you need to do there.
Okay. How much overhead does it does all of this add to a function invoke? I know you've done some good optimization with the tracing and X-ray, but I mean, if people look at this and they go, "Oh, I'm adding a lot of code into my Lambda functions. I'm a bit worried about the performance impact of that and cost."
Okay, so the parsing. Okay, so we're using Pydantic a lot of behind the scenes. Pydantic is very optimized. It's performance-oriented parsing and validation libraries. So I think the numbers are on the Lambda Partos. They did a benchmark, a very, very strict, very comprehensive benchmark, and it doesn't add a lot. I mean, it's basically, you're not going to feel it. And
okay.
And about feature flags, so app-config is an API call to app-config, but you also have a cache that it lives on between invocations. So you can define to have like 5 minutes cache. So the next time the function is going to get invoked, the cache is still alive. You're not going to do an API call, so you're not going to pay the price. And I think it's about 200 milliseconds, I think, for app-config, something like that. But if you have the cache, then it's basically nothing.
Yeah. Perfect, Ran. We are fast approaching the end of the hour. Is there anything sort of in 20 or 30 seconds that you'd like to wrap up? I mean, I'm not often one for sitting and looking at code, but I think this is fantastic just to go through all the detail that you've put in here. I think is amazing and super useful.
Thanks. Well, first of all, I'm really looking for feedback. So if you think that I'm doing something that I should be doing better,
he's done all this work for an amazing open source tool, and our feedback would be super useful.
And everything that I've mentioned, and I also go into more detail. All the things that I'm talking about here, they have their own posts on my website, roundthebuilder.cloud. And it's also in the documentation. I have links to the specific blog posts about CDK best practices and testing best practices, logging, everything that you see here. It started as a blog post, and this is the repository that I use to really emphasize the points in my blog posts.
Perfect. So yeah, lots of info on Ran's blog, all backed by code that you can download and try on GitHub. So yeah, really thank you for spending your time with us today. For all general information on serverless at AWS, head over to serverlessland.com. Just loads of code snippets and examples and event-driven architectures and anything about serverless on AWS. Ran, thanks so much for joining us in Serverless Office Hours. Appreciate your awesome wisdom, and hopefully we're going to be able to chat to you soon. Thanks so much.